Okay, we are now in the chapter 3, the 6th section, so 3.6, the topic of curve sketching. And the beautiful thing is that you have some pretty awesome skills right now that you might not even know what you can do with them yet, but I'm going to show you something that's fairly amazing. So if I asked you to graph some function, so say for example the following function. Now, in previous classes, how did you graph things? If you had to graph by hand, well, you might use some symmetry, some properties of symmetry, but don't you agree with me? The majority of what you did in previous classes would just have a whole bunch of dots, and you connected them, right? But let me see if you can understand my point. If I give you a few dots, how are you going to connect from one dot to the other? Are you going to just draw a straight line? Are you going to maybe connect in a concave up fashion or connect in a concave down fashion? Do you see that to get a quality graph, you're actually going to need a lot of points? In fact, that's what your calculator does, is it produces a lot of points that you could connect from dot to dot and get a quality graph. But you're going to need a lot of points to get a quality graph in previous classes, but not with some of the skills that you have in your calculus class. So what are we going to do? Well, we're going to use just the culmination of skills in the previous sections. The idea of concavity, the idea of increasing, decreasing, and the idea of horizontal asymptotes, and then we're going to grab a few other key ideas from pre-calculuses like intercepts, x-intercepts, y-intercepts, and we're going to put all of this together. And what I'm telling you is, in just a few minutes, you're going to be able to graph functions like this. I'm not saying like just a crappy graph. I'm saying a quality graph in no time. Ready? So what do you need? Well, what I've done is I've taken the liberty of giving the first derivative and second derivative. And since this section is all about taking the previous sections and putting them together into one package, what I want to do is I want to start moving through this material quickly, right? So let me go ahead and state that the critical numbers the critical numbers are going to exist. Let's take a look at that first derivative. Well, can you make that numerator equal 0? You can. You can make that numerator equal 0 when x equals 0. Can you, now let me ask, can you make that denominator not exist, right? So dividing by 0. Well, if you were to choose x is equal to -2, you would end up with -2 squared is 4. You'd end up with 4 minus 4, which is 0. And it's the same thing if you were to choose +2. Each of those is important. So those are your critical numbers. Let me add some information. This is coming out of some pre-calculus. So the x-intercept, all right, where the graph crosses the x-axis, the x-intercepts exist at -3, 0, and 3, 0. So far we have 2 points on our graph. Now the y-intercept This is where your graph crosses your x-axis. Your y-intercept is going to be at the point 0, 9 halves. So now we have 3 total points on your curve. Now I'm gonna kind of move to the next page for just a second and plot those. Ready? So if my eyesight will allow me to see, I believe we're gonna have, so here is an x-intercept at positive 3, 0, and we also have a x-intercept at negative 3, 0. All right, and then we have a y-intercept at 9 halves, so that's 4.5, so that should be about right here. Okay, let me go back to the previous page. Okay, so let's look at this original function, right? This is the original f. And more importantly, let's look at the denominator. Are there any vertical asymptotes? Now, I'm going to be lazy. I'm just going to write v. Well, I was going to write vertical VA, but I don't want you to get confused. Vertical ASY. I'm going to just leave it abbreviated. So vertical asymptotes. All right. So looking at this original function, I think you will agree with me that x cannot equal positive 2 or negative 2. Agreed? Either way would be dividing by 0. And so in that case, that would mean that you have vertical asymptotes, right? Those aren't holes in the graph. Those are vertical asymptotes at x equals 2 and x is equal to negative 2. Now, I'm going to go back to that to the next page, and I'm going to go ahead and plot those vertical asymptotes. All right, so I have a vertical asymptote at here is x equals 2. And I also have a vertical asymptote at x equals negative 2. I'm not going to label. I'm just going to keep it as a dotted line. But those are my vertical asymptotes. Okay, so I know my graph cannot cross those lines. Let's look at the idea of horizontal asymptotes. So the horizontal asymptote, let me go ahead and write horizontal asymptote, and then I'll do the work off to the right. That's not how I wanted to abbreviate it, but let's try that again. Okay, so let's see if there is a horizontal asymptote, if one even exists. Well, so as I said, you can use the limits at infinity definition, or you can use your pre-calculus technique. Either way, you could, now if you have to revisit that, then you'll have to revisit that. But either way, what you would figure out is that the limit is equal to 2, which basically means there's a horizontal asymptote at y is equal to 2. So now I'm going to go back and graph that horizontal asymptote at y equals 2. All right, now, can your graph cross a horizontal asymptote? Because we know it can't cross a vertical asymptote, but can it cross a horizontal asymptote? Well, sure, yes. I mean, it's okay to cross a horizontal asymptote. what the horizontal asymptote says is that over time, so for example, I'm going to erase this, but if you have a horizontal asymptote, you'll often see graphs, especially periodic functions, that'll cross multiple times, but over time, it'll start to ride that horizontal line. It'll start to converge onto that horizontal asymptote. So, all right, let me now, at this stage, I have some information. So what I'm going to do at this stage is go to the next page and look at and use these critical numbers. All right, so let me grab these critical numbers, and let me go to the next page. And so I'll park these here. So, and then what we're going to do is we're going to set up that table, right? The table of multiple columns. And we're going to use the 0, the -2, and the +2 to chop up our number line, right? So that means we're going to end up with intervals from -infinity to -2, and -2 to 0, and so forth. So that's what I'm about to do on the other page, and then we'll start to see what information that table can give us. Ready? So let me go over here, and I'm going to erase these critical numbers that I just dropped right here. I just want to have them there while I'm setting up my intervals. So I'm definitely going from -infinity all the way to -2. Right? I had a big. You think about it, you have a string, and then you make 3 cuts. If you make 3 cuts, that means you're going to have 4 pieces of string. So now I'm going to go from -2 to 0. I'm going to go from 0 to +2. And finally, I'm going to go from +2 all the way out to infinity. All right, so let's go ahead and see what information we can grab from here. So now you remember that in the sections prior to this, we would set up the intervals, and then what would you do? You would pick a test point, right? You would pick a test point that exists in that interval. And then what would you do with the test point? So for example, -3 exists in the interval -infinity to -2. But what would you do with the -3? Well, we're going to end up plugging it into the first derivative and the second derivative. Okay, now the first derivatives and the second derivatives on the previous page. So, but the real question is, once you plug it in, what are you getting back out? Right, so we're going to plug in to the second derivative and the first derivative. Okay, so, well, if the sign of the first derivative is negative or positive, let me do this right now. So I'm going to go ahead and tell you that if you pick a test point and plug it into your first derivative, you would get a negative value here. And if you plug it into your second derivative, you would get a negative value here. Let me go ahead and give you the rest of these. If you pick a test point in the second interval and plug it into your first derivative or second derivative, you would get a negative value here. You would get a positive value here. I'm going to finish this. If you pick a test point from 0 to 2, like if you picked 1 and plugged it in, to your first derivative, you get a positive number. To your second derivative, you would get a positive number. And finally, if you picked a point in 2 to infinity, like 3, if you plug that 3 into your first derivative, you would get a positive number. If you plug it into your second derivative, you would get a what? You would get a negative number. All right, now, What information does this give us? So let's start. What is a negative first derivative mean? That means it's decreasing, right? Remember that? A negative first derivative means decreasing. What does a negative second derivative mean? It would mean it's concave down. Let's continue. So next interval, negative first derivative means decreasing. Positive second derivative means concave up. Positive positive would mean that your function's increasing while also being concave up. Positive negative would mean your function is increasing, but it's concave down. And now, armed with these vertical asymptotes, horizontal asymptotes, and these x-y intercepts, I'm going to try to sketch the graph of this function. Okay, so let me do this part slow because everything has been a review up until this part right here. So right now I'm going to sketch, I'm going to be decreasing while concave down from negative infinity all the way to -2. All right. Are you ready? So let me do my best. So that would mean that I'm going to be coming from negative infinity. I'm decreasing while also being concave down. And that gets me to, so negative infinity, I got to go through the x-intercept all the way to 2, but I don't have to actually cross 2, right? So I'm just going to continue to decrease by being concave down. So that's what the graph looks like there. Now let's look at the interval -2 to 0. Okay, so from -2 to 0. So I should be decreasing. Right, I should be decreasing while being concave up. All right, so I'm coming from this direction. The whole. Well, let me erase that a little bit. Do a little bit better than that. So I'm decreasing, 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 all the way. I got to cross that y-intercept the whole time. The whole time I'm decreasing while remaining concave up. Okay, so that's decreasing, then concave up. Okay, now, when I get to once I get to this y-intercept, now I'm going to see what happens as I go from +0 to 2. Well, the whole time I should start to go up. I should start to increase and still be concave up. So you kind of see how this is going to start. I'm increasing. Now it's starting to increase. But the whole time I'm concave up. Now the last interval is what happens as you go from 2 to infinity, as x goes from 2 to infinity. All right, well, it says I should be increasing the whole time, but concave down. So in that case, I'm going to be increasing. So I'm increasing. Let me go through the intercept. I'm concave down, but I'm still increasing, and I'm starting to ride that horizontal line. That is the graph. Well, it's the best that I can do with this stylus, but that is a really remarkable graph. And let me go ahead and state, you would need a lot of points, right? You would need a lot of points to be able to produce a graph like that without calculus. But with calculus, you only needed 3 points, some some asymptotes, and a little bit of information about your derivatives. This is what the true graph looks like, taken from Desmos. All right, now I'm going to conclude. This is the only video that I'm going to do for curve sketching, which is 3.6. It is one of these techniques that it's a culmination of all the previous videos. So it's if you were able to follow me through the previous videos of this chapter, then it's just putting it all together. So you just get some practice time on your own, but it's really amazing. It's really quite remarkable. And I will see you with when we get to the next section.